welcome to Precalc Lifeline. This is episode 2, and we will be discussing reference angles. So reference angles are acute angles formed by the terminal side of an angle and the x-axis. And an important word in that definition is the word acute. Reference angles will never be 90 degrees or more. You will never have a reference angle of 130 degrees or 270 degrees. Never, never, never. So a quick drawing of what reference angles look like is something like this. In the first quadrant, a reference angle might look like this, and it's measured from the positive x-axis to the terminal side. And actually, usually in the first quadrant, unless there's been rotations added, the first quadrant angle is actually also the reference angle because it is acute and it's measured from this terminal side to this x-axis. And another thing is reference angles are always positive. You'll never have a negative reference angle. So usually in the first quadrant, your reference angle will actually just be your given angle. In the second quadrant, reference angles look something like this. They're measured from the negative x-axis to their terminal side. And how I like to think about it is if you had an angle that was in the second quadrant. Your reference angle in degrees or radians would be what it takes to get to either 180 degrees or pi radians. How much does it take? What do you have left? How much left can you go? Any of those, right? And a quick, how you denote reference angles is actually theta prime. So a little apostrophe, if you will, after the theta. In the third quadrant, reference angles look like this. And if you were to have an angle that goes around into the third quadrant, your reference angle is like how much does it bleed over just past the x-axis. It's just this portion of it. And in the fourth quadrant, we go back to, the how much do you have left before you hit it. So your reference angle is measured from here to here, but if you had a given angle that went all the way around, your reference angle is basically what is the measurement of how much you have left before you hit the x-axis again. And an important thing to notice is that your reference angles will never be connected to the y-axis. You will never, ever, ever have reference angles that are measured from here to there, or even here to there. And just likewise, you'll never have this. These are where your reference angle is always connected to your x-axis. So it might be here, it might be here, it might be here, or it might be here. But never, never, never are you going to have reference angles connected to the y-axis. So let's jump into an example problem. Say we have the angle 210 degrees. Draw my y and x-axis. 210 degrees is in the third quadrant. And our problem is to find the reference angle. So we know that this negative x-axis is 180 degrees. And this angle is 210 degrees. Your reference angle in the third quadrant is basically how much do you bleed over, right? What is the distance from the terminal side of the angle to the x-axis? Well, 210 degrees is actually 30 more degrees than 180 because it's sort of like a subtraction problem. 210 minus 180 degrees equals 30 degrees. So theta prime equals 30 degrees. So this angle bleeds over the x-axis 30 degrees right in here. Let's do another example with degrees. Let's say our angle is 300 degrees. Well, if we were to graph it, it'd look something like this. It would go all the way to the fourth quadrant and stop because this is 270 degrees and this is 360 degrees. So it'd stop right there in the fourth quadrant. And to find our reference angle, we have to see what is this angle right here from the terminal side to the x-axis. How many degrees is that? Well, if we already have 300 degrees and the x-axis is 360 degrees, then that means we have 60 more degrees to go until we reach the x-axis. So theta prime equals 60 degrees. If we were to look at it like a subtraction problem, it might look like 360 degrees minus 300 degrees. And we get those 60 degrees. Let's do one more example in degrees. Say our angle is 45 degrees. What is our reference angle? So, what's the distance from the terminal side to the x-axis, or the x-axis to the terminal side? Well, it's just 45 degrees. So theta prime equals 45 degrees. But say we were going in the negative direction. Say we were going negative 315 degrees, which is coterminal with 45 degrees. And if you want a refresher on coterminal angles, my last video discusses that at length. So what is the reference angle of negative 315 degrees? Well, it's still this 45 degrees because we still have 45 degrees more before we connect with this x-axis. 45 degrees is still the distance from the terminal side of the angle to the x-axis. And it wouldn't be negative 45 degrees because negative 45 degrees would actually be an angle in the fourth quadrant. Reference angles are always positive because they're not measured in standard position. So let's do some examples in radians. Say we have the angle 5 pi over 6, and we want to find what the reference angle of it is. Well, 5 pi over 6 is in the second quadrant because one full rotation is 2 pi. And a half rotation is pi. But a half rotation can also be written like 6 pi over 6, because it's the same thing. So 5 pi over 6 is in the second quadrant. Let's graph that. So let's find the reference angle. Well, if we know that this is 5 pi over 6, and that the x-axis is at 6 pi over 6, then we know that we have one more pi over 6 to go before we reach it. We know that's how much we have left before the terminal side is on the x-axis. So, the reference angle is pi over 6. Let's try one more example in radians. Let's find the reference angle of 4 pi over 3. So 4 pi over 3 is in the fourth quadrant because this is 3 pi over 3, right? So we're going to go all the way into the third quadrant, 4 pi over 3. Now, what's the reference angle of that? Well, in the third quadrant, it's how much you bleed over. What is the distance from the terminal side to the x-axis? Well, if this is 4 pi over 3, and this is 3 pi over 3, then we know the distance is pi over 3. So theta prime equals pi over 3. Thank you so much for joining me on Precalc Lifeline today. If you want more math help in the future, please subscribe. If you have any questions, ask away in the comments.